Okay, welcome to the second lesson of the year here, which is going to be on section 1-4, where if you remember in 1-2 and 1-3, we talked about different sets of numbers, and then we talked about how to simplify algebraic expressions and then evaluate those expressions by substituting in a number. Remember that an expression is not equal to something, so that's why we're evaluating rather than solving. But if you notice today, what we're going to take a look at is we are now solving linear equations. Okay, that's what the difference now. We're going from expressions into equations. We're going from evaluating into solving at this point. Good news is this lesson should be a little bit shorter than the last one. So first off, if we talk about the different steps to solving an equation, okay, as we go through and we take a look at that, there is a decent step that goes on here. And so if we take a look, blow this up a little bit. So step number one, anytime you're solving an equation, would be you want to eliminate any fractions that are involved, because the fractions a lot of time are what make the problem difficult. So we can multiply all the fractions out in one step, and I'll show you how to do that in an example later on, using the least common denominator. Okay, so we're going to look at that. We'll get to that, like I said, a little bit later. Number two, we're going to simplify each side of the equation then. So just like we were doing, we're going to simplify each expression on each side of the equal sign. Okay, and when I say simplify, what do I mean? We're talking about doing any distributing that you have to do. I'm talking about combining any like terms that you might have to combine to kind of clean things up a little bit. And then once you've done all the simplifying, then you're going to keep the equation balanced as you start to then solve for whatever variable is in the problem. Okay, so what I mean by that is if you add something to one side of the equal sign, then you got to add it to the other side. Multiply on one side, multiply on the other. And then finally, our last step then is once we get the variable by itself, then we have to solve for it. Okay, and again, I'll explain all these steps. We'll use these steps in some examples today. So if we take a look, example number one is we're gonna go through and solve this. So if you take a look at this problem, there is nothing that we can do. If we kind of talk about, there's 5x plus 19 is the expression that's on the right-hand side. 3x minus 5 is the expression on the left-hand side. And so we're going to take a look and we're going to try to solve that. Well, we had said eliminate any fractions was number one. Can't do that here. We don't have to worry about that. Number two, we had said to go through and do any simplify each side, combine like terms, distribute, that kind of stuff. Well, on this side, there are no like terms. Same thing over here. There's no distributing. So we're actually down to step three, where we're going to start moving things around. Notice I've got x's on both sides of the equation. I need to get those x's together. So I'm going to take this positive 3x, and I'm going to subtract that 3x so that it eliminates it on the left-hand side. But then again, remember to keep the equation balanced. So we have to do the same thing on the right-hand side. Okay. When I do that, then I'm going to bring everything down. So that means this negative 5 comes down. That means this 5x minus 3x gives me a 2x. And I'll bring the plus 19 down. Okay. At that point, by the way, just a quick heads up, that if you wanted to subtract 5x to the other side and do it that way, that would have been okay as well. You would ultimately still get to the same answer. Your process would look a little bit different with negatives and things like that, but the answer in the end would end up being the exact same answer. Okay? And now at this point, we're going to take this positive 19 that's right here, and because I'm trying to solve for x, I want to get this 2x. I want to get that term all by itself. So that means I got to get rid of the 19. So we're going to subtract 19 to get that out of there. That'll cancel out. Do the same thing to the other side of the equal sign. Put those together. If I've got 5 negatives and then I have 19 more negatives, that is a total of 24 negatives. Bring down the 2x that's still on the right-hand side. And now our last step, when I said solve for the variable, the term that had the variable in it is all by itself, and now I have to actually get the variable by itself, meaning we're going to divide by 2 to get that out of there. And ultimately we end up with x equaling negative 12. Okay. So this is all stuff you did back in Algebra 1, but we're going to review it because obviously some of the main steps that we talked about back over on the previous page is we're going to build on those all year long and use those. So in this case, we end up with negative 12. One of the key things I can tell you is you got to try to be organized. The more organized you are, the better off that you're not going to make a mistake as you work your way through this. Okay, so that's where we are headed. So let's go to the next example here. And again, if we look on the right-hand side, there's nothing that I can do on the right-hand side. And there's no fractions here, so I don't have to worry about that. But on the left-hand side, I can simplify this a little bit. I can take this 6 and distribute it into the parentheses. So we're going to start with that. So take that 6 and we're going to distribute. That gives me 6 times n is 6n. 6 times negative 4 is negative 24 equal to 3n. And now at this point, these two terms are not like terms, so this is simplified as far as I can. And now we're going to go through and start moving some things around. Okay? So I want to get, since there's n's on both sides of the equation, I want to get them together. So I'm going to subtract 6n from the left-hand side. That will allow me then to get all of the n's together on the right-hand side. I'm going to bring this negative 24 down. Don't forget the negative. Be careful, organized, like I said. Make sure you pay attention to those details. That's the other part is the more you pay attention to the details, the better off you are. We have a positive 3n minus 6n, so that's going to give me a negative 3n. And now our final step here is to get n by itself. So I'm going to divide both sides by negative 3 to get the actual n by itself. Remember, whatever you're solving for, you got to get rid of what else is there. So I'm leaving the n alone, getting rid of the negative 3. So at this point, n, in that case now, equals a positive 8. Negative divided by negative is positive, and we have our answer of n equals 8. Okay? If I were to substitute that back into my original problem up here, into both of these, we would get a true statement. We'd get something where, like, matter of fact, if I do it, here's 8 minus 4 is 4, times 6 is 24. So on the left-hand side, I get an answer of 24. If I plug 8 in over here, I also get 24. So it's a true statement. I know that I did it correctly. Okay? So that's an easy check, too. All right, now we're going to get a little bit more complicated where we got to do a little bit more on this problem. So I'm going to start off with, on the left-hand side, I'm going to take this 2 and distribute. So 2 times 4x gives me 8x. 2 times negative 3 is negative 6. I still have that plus 3x, so I'm going to write that down. Okay? I'm going to keep going, too, because I can, on this left-hand side, because I can go through and simplify that further because I've got some like terms. I can put the 8x and the 3x together. So that gives me an 11x minus 6. So there's the left-hand side. Now if we go to the right-hand side, this one's a little bit tricky because technically there's a 1 that's sitting right here. That's what's getting distributed, is that negative 1. Okay, you're distributing the negative 1, which means we end up with 15. This now becomes a minus 2, and this then becomes a plus 13x. And again, I can go through and combine some like terms. I've got the 15 and the negative 2 that I can put together. That gives me a 13 plus 13x. And now we're right back to where we were on the previous two examples. Now that we've simplified each side, now we can go through and we can kind of move some things around, start adding and subtracting stuff from each side. So I'm going to subtract 11x. I'm going to bring that over here to the right-hand side. Those cancel out. We get a negative 6 equal to 13 plus 2x then. And now I've got to get that 2x by itself. So the 13 has to go to the other side. Those cancel. We end up with a positive 2x on the right-hand side. And on the left, again, if you're thinking about this, easiest way I've found is think about this as actual like negatives and positives. Here I've got six negatives right here, and I've got 13 more negatives down here. If I put those together, that gives me a total of 19 negatives. Okay? And now my last step, divide both sides by 2, and we end up with x equaling a negative 19 halves. And you can just leave it like that as an improper fraction. Okay. This one turns out to be a nice decimal, so I'd accept a decimal as well. But generally, if it turns out that it would be a rounded decimal, then in that case, I don't want you to round it. Okay. I want you to go through and I want you to just leave it as a fraction, reduce the fraction if you can, but I don't want you to round the decimals. Okay. All right, last couple of examples here. I got two final examples where now we're going to add in some fractions, and then we'll get to the homework. So in this case, we said step number 1 was to eliminate all fractions. So in this problem, since we are dividing by 7, I'm going to get rid of everything. I'm going to get rid of that fraction by multiplying this entire equation to begin with by 7. In that case, it's the only denominator I have. So if I take 3/7 and I multiply by 7, I'm going to now distribute this to each one of these terms that's in parentheses here. Well, when we take 3/7, I'm going to do this off to the side for a second. If I take 3/7 times 7, think of that as 7 over 1, the 7's cancel out, and I'm left with the 3. So this becomes 3x. That's 7 in the denominator canceled out from the 7 that we're multiplying by. I multiply the 2 by the 7, that gives me 14. And I multiply the 3 by the 7, gives me 21. And now this problem that we just came up with is a whole lot easier to solve than the problem was originally. Okay? And now we solve it like we normally would. Subtract the 14. Those cancel. We get 3x equals 7. Divide both sides by 3. And we find out that x equals 7/3. And again, you can just leave it like that. If you wanted to write it as 2 1/3, you could do that. If you wanted to write this one as 2.3 repeating, I'd be okay with that. Because again, you're not rounding as long as you put the repeating sign on it. All right, last example then. We'll put a kind of a complicated one in here. So if we go through, let me move this up, where we've got multiple fractions. And now we take a look. I can get rid of all of these fractions, just like I did up above, by multiplying by a common denominator. The common denominator of 3, 4, and 6. Now, not common factor, it's common multiple is what we're talking about. So the first number that 3, 4, and 6 all go into, in this case, is 12. So I'm going to multiply everything by 12. So when I multiply the 1/3 by 12, again, remember, just like in the last problem, we're now going to distribute this to each one of these parts. Okay? Everything in here is going to get distributed. So when I multiply the 1/3, and again, I'm going to do this off to the side, the 1/3 times 12, 3 goes into 12 4 times, and that's what you're left with then is 4x. Okay. When I multiply 1/4 of 12, 4 goes into 12 3 times, so that ends at 1/4 of 12 is 3. Equal to, don't forget, even the problems that don't have fractions, we have to multiply by every term. Okay, so even that x has to get multiplied. So we're going to then get 12x. And then finally, 6 goes into 12 2 times, so 1/6 of 12 will give you a -2. And now, if you look at this equation that we have, this is just like the first one that we started with, and it's a whole lot easier than what it looked like at the beginning. So now if we start moving stuff around, subtract 4x over to the other side. Those cancel. Since I moved the x's over here to the left, I'm going to, at the same time, I'm going to take this 2 and I'm going to add it to the left. Get rid of that. I'm going to kind of do 2 steps in one here. So I end up with 5 equal to 8x. Divide both sides by 8, and you end up with your final answer of x equal to 5/8. And again, you can just leave it just like that. Okay? So this is something, these fractions are something that we'll continue to work on as we move forward. But it's something that it's a nice way of getting rid of all the fractions in step number 1 and then not having to deal with it. So that's something I'm sure we'll talk about when we're in class, and we'll go over again if we need to. So there's the lesson. Your homework for this one is going to be worksheet 1-4. Again, it'll be out on Canvas. I'll hand it to you. You should have it with class as well, and we'll go from there. Hopefully that made sense. Good luck with everything. Good luck on the homework, and bring some questions with you to the next class period that you're in class. Okay.